This is a forensic teardown of the claim that the first Transcontinental Railroad was built between 1863 and 1869 by crews with picks, shovels, and black powder. And we are going to test that claim against the stone, the tool marks, and the money trail. The official line says simple tools carved tunnels and quick wooden trusses jumped canyons. But right beside that story sit smooth tunnel walls with arcing machine signatures and megalithic granite bridge foundations that do not match the speed-first playbook. Do the simplest check. Set a hand-drilled black powder wall next to a surface with clean, repeatable arcs. Because if those arcs are present, how can a hand tool story survive a surface that reads like a rotary machine print? The baseline claim is blunt. Hand labor with hammers, chisels, and low-velocity black powder cut through hard granite in a hurry, and the result should look rough and fractured. Look. The constraint check is to inspect the wall texture for shattered cones and ragged, uncontrolled fractures that black powder is known to leave. If instead you map repeating arcs that hold a constant radius along the length of a tunnel face, you have a mechanical fingerprint that does not come from a chisel strike or an irregular blast. If the wall reads smooth and rhythmic instead of torn and chaotic, why are we told a story of brute force when the surface reads like guided power? Black powder is a low explosive, meaning it pushes, not shatters, with a slow burn rate that follows the path of least resistance. Think. The physics check is to map the fracture patterns it leaves in dense rock like granite. It creates radiating cracks and a pulverized zone around the borehole, but it lacks the shockwave velocity to shear rock cleanly over a large, smooth face. A wall produced by black powder should be a landscape of craters and jagged plains. If the physics of the explosive cannot produce the finish we see, why is it listed as the primary tool for the job? Hand drilling in granite is a brutal, slow process of strike, turn, with steel bits that dull and break. Be honest. The labor check is to time the process. A two-man team might drill a few feet of borehole in a full day. Now multiply that by the hundreds of holes needed for a single blast section that might advance the tunnel face by only a few feet. The calendar simply does not support the progress rates claimed. If the man-hours required for hand drilling alone would stall the project for years, how did they finish on a timeline that suggests a much faster cutting method? Every tool leaves a signature, and the tunnel walls with smooth, arcing grooves are a signature of a rotating cutter, not a hand chisel or a powder blast that splinters and tears. Reality does not care. The direct test is surface microscopy, or even close-range casts of the striations to measure spacing and arc radii along a chord. Hand strikes wander, and powder fields scatter, while a guided head repeats its path with geometric precision. If the striations keep cadence like a machine, why does the official account insist on hand rhythms that never produce? That beat. Granite is a hard, brittle rock that punishes hand drilling, and work at almost a foot per day per face is already a stretch before you add the claim of machine-smooth finishes left behind. You cannot cheat constraints. The output test is to line up a modern hand-to-granite case, raw chisel work on similar rock under controlled swings, and photograph the surface for gouge depth variability and step lines. Hand pressure wobbles and leaves uneven bites. If the railroad walls look like they were milled, while hand-drilled reference panels look torn and stepped, How can anyone square that mismatch without calling it fiction? A mechanical boring machine capable of leaving such marks requires immense and constant rotational force, or torque, to cut through granite. Stop buying it. The power source check is to identify the engine required, steam or otherwise, and then locate the logistical footprint for its fuel and water. A large steam engine consumes tons of coal and thousands of gallons of water per day, which has to be hauled to. A remote tunnel face. If there's no record of a massive fuel and water supply chain dedicated to the tunnels, where did the energy to drive the cutter come from? The bridge story says, "Quick how trusses on top," which fits a schedule driven by speed. Yet on the ground, you meet granite foundations made from huge, tight-fitted blocks that act like permanent anchors, not temporary footings. Look, the hard check is load versus lift. Weigh the largest visible stones by volume and density, and compare that to a steam derrick's safe lift window from the 1860s. Then add rigging angles, footing strength, and swing radius. If the lift math blows past the documented gear's limits, how do you stack stones that outclass your crane? The process of quarrying even one of these multi-ton blocks is a major industrial operation in itself. Think. The extraction check is to map out the steps, drilling lines of holes, driving wedges, and patiently splitting the block from the bedrock without cracking it. This takes time and skill, not just brute force. Now, where are the massive period-appropriate quarries with the waste piles and tool marks that would prove this scale of production was happening? If the source of the stones is a mystery, how can the story of their placement be a fact? Once a block is quarried, it must be dressed, meaning its faces are squared and smoothed to fit tightly against its neighbors. Be honest. The skills check is to examine the joints between the blocks. Tight, mortarless joints are the work of master stonemasons, a highly paid and specialized trade. The payrolls for the railroad list thousands of general laborers, not hundreds of master masons. If the skilled hands required for this work do not appear on the books, who actually shaped these stones to such a high tolerance? The race narrative says crews laid 1 to 10 miles per day when the line was flat and clear, which points to fast, light, and modular choices wherever possible, not megalithic granite that eats time. Reality does not care. The schedule check is simple. List the steps. To quarry, dress, move, and set a multi-ton granite block. Cut, square, transport, align, and bed. And stack that cycle against a pay-by-the-mile incentive. If time is money and heavy stone kills time, why choose a method that bleeds your payday? Transporting these blocks from a quarry to the construction site over rough, pre-railroad terrain is a monumental challenge. Do the simplest check. The logistics check is to calculate the ground pressure of a wagon or sled carrying a 10-ton block. It would sink into soft ground and require a wide, reinforced roadbed to move it all. You'd also need huge teams of draft animals. Where is the evidence of these purpose-built, heavy-haul roads running from quarries to the bridge sites? If the transport network required for the job is nowhere to be found, how did the materials arrive on site? The lifting claim runs into the same wall when you match stone to hardware from the period that operated with strict, safe limits, because a block and tackle plus a steam derrick only handles what its rigging and base can carry. You cannot cheat constraints. The field check is ground truth. Find imprints for big-footed cranes, crushed pads, and reinforced staging flats that would have to exist near placements. The ground must be prepared to support not just the stone, but the machine lifting it. If the ground is clean and the stones are colossal, where is the trace of the gear that supposedly moved them? Any practitioner will tell you the rule. You spec the lift before you set the pick. And if the lift is heavier than the crane and rigging allow, the job does not happen. Full stop. Stop buying it. Pick one of those foundation stones. Peg its rough weight by known granite density and its visible size, and then pit that against a documented steam derrick's practical lift window. The official safe working load of these machines was often a fraction of their theoretical maximum. If the rock is bigger than the bite, are we looking at an impossible in practice claim, dressed up as history? The pattern does not stop at one bridge or one tunnel, you see. Recurring signs of high-precision work that looks like slow, deliberate stonecraft, not sprint construction. Look, the system check is to mock up a plausible build chain. A quarry with cutting crews, heavy sleds or wagons, staging yards and site cranes, and then ask for receipts in records, maps or supply logs. This isn't one project. It's dozens of heavy industrial sites running in parallel. If there is no footprint for a heavy stone pipeline feeding dozens of sites, how does a speed-first railroad run a shadow megalith project at the same time? The tunnel finish reads like mastery over granite, not a grim fight against it, and the foundations read like forever builds, not throwaway supports for a wooden truss meant to be replaced. Think. The input-output check is clean. If your inputs are hand tools and black powder, while your output is smooth, regular, machine-like geometry and megalithic stability, then the inputs do not produce the output. If output outclasses input, why would we protect the input story instead of updating it to fit the parts in front of our faces? This is not a minor discrepancy. It is a fundamental contradiction in the means of production. Be honest. A project's final form is always constrained by its tools, its budget, and its schedule. The official story presents a set of constraints, simple tools, tight budget, breakneck speed, that are directly violated by the physical evidence of precision-machined tunnels and massive, expertly fitted stone foundations. If the constraints of the story do not produce the artifact, then the story itself is a fiction. The money angle is plain. The builders were paid per mile by law and subsidy, which set a simple rule. Faster track meant faster pay. And that means time sinks got cut. Reality does not care. The incentive check is to read the payment language in the acts and match it to the record of fast track laying days versus slow, heavy stone days. The business model was land grants and government bonds, both awarded per mile of completed track. If the cash landed with speed and miles, quality that burns calendar makes no sense. How trusses made sense for the sprint. Wood and iron, easy to source, easy to raise, and fast to replace later when cash was steady. Yet the bases under some spans look like shrine-grade stone. Do the simplest check. The cost check is ugly on purpose. Tally skilled mason time. Long lead for granite dressing, and risk of breakage in transport. Then set that burn next to quick woodwork by semi-skilled hands. Granite construction is an order of magnitude more expensive and slower than timber. If granite multiplies labor and risk, why choose it when the pay clock punishes delay? The financial risk of choosing slow, expensive methods on a project funded for speed cannot be overstated. Stop buying it. The cash flow check is to model the weekly expenses of a crew of masons and heavy transport versus the income from laying track. A delay of even a few weeks on a single granite bridge could halt progress on miles of track, choking off the project's only source of revenue. Who would underwrite such a financially self-destructive choice? The granite pattern is not a one-off oddity. You see it pop up along the route, like a drumbeat that never fits the budget logic of a race. Look, the resource allocation check is to stack even a back-of-the-envelope tally for multiple megalith sites against a pay-per-mile cash-in flow and known fast-track days. You are diverting your best resources, people, animals, wagons, to a slow, low-reward task, while the primary, high-reward task of track laying starves. If the sum of stonework would have choked cash and calendar, who carried the difference when the ledger should have gone red? The workforce on paper reads like labourers and foremen with a few engineers, not platoons of master carvers and machine techs whose craft takes years to grow and costs real money. Think. The skills check is to scan payroll rolls and job notes for stonemason grades and machine operators. These are distinct, high-wage professions. If the hands were hired to move dirt and spike rails, not to cut tight stone joints or run high-power cutters, then where did the skills for megalith fit and machine finish come from? The mismatch between the speed reward and the slow, permanent output is not a quirk. It is a system-wide clash that any builder recognizes as nonsense. Be honest. Align the reward, miles per day, with the method, granite blocks and machine smooth bores, and you get a jam that spreads risk and delays payment. The entire purpose of the enterprise was to connect two coasts quickly and get paid for it. If the risk climbs and the pay stalls, who benefits from the slow choice when the sponsor pays for fast movement, not monuments? The logistics claim says wagons, mules, and the unfinished railroad fed the front as it pushed through mountains, which is barely enough for wood, iron, food, and powder, let alone megalith stonework. You cannot cheat constraints. The pipeline check starts at the quarry. Identify the cut source for those dressed blocks, trace the route over rough ground, and count the trips needed for the visible work. That supply line competed for the same limited resources as the track-laying crews.
If you cannot show a road stout enough, wagons low enough, and draft
power strong enough, how did multi-ton stones arrive on time at multiple sites? Moving one big block over raw country is a fight with grade, mud, and breakage, and doing that in parallel for many sites, while also laying track pushes any transport line past its limits fast. Reality does not care. The bottleneck check is to time the cycle from quarry to site and back, then stack that cycle count against track-laying windows and crew availability. One heavy haul might monopolize the best animals and handlers for a full day. If one heavy haul eats a day while track gains demand the same day, where do the hours and hands come from without stalling both jobs? The claim of clearing debris from pre-existing routes or tunnels flips the material balance because cleanup moves rock out, but at a scale far below full excavation from solid granite. Stop buying it. The volume check is countable. Measure
the fills and embankments along the line, and compare that bulk to the
modelled spoil from cutting fresh tunnels and deep rock cuts. Creating a tunnel produces a mountain of waste rock, roughly equal to the tunnel's volume. If the fills do not hold the expected mountains of waste, isn't missing debris a tell that most of the void already existed? If the work was mostly clearing, rather than drilling new, debris piles should be modest and patchy, not the huge, uniform dumps you get from full section blasts. And that contrast is measurable. Look. The ground check is to core a few fills, log the mix of shattered rock versus weathered material, and add up the total mass. Freshly blasted rock is angular and sharp. Old debris is often rounded and mixed with soil. If the totals cannot match the supposed fresh-cut volumes, do we call the book correct or the ground correct? A true heavy industrial project needs fuel by the ton, spare parts, skilled mechanics, and service bays for complex cutters and cranes. Yet the written story leans on mules, sleds, and grit. Think. The support check is inventory. List the fuel, water, and spares needed to keep a large mechanical, boring system alive for weeks. Then point to depots and records. A machine that can bore granite is a complex system that breaks. Where are the forges for repairing broken cutter teeth, the mechanics, the stockpiles of lubricants? If those lifelines do not exist, how did a ghost machine cut perfect arcs in hard stone? Precision is not an accident. The arcing marks march in sequences that look guided, repeatable, and geometric, which reads like a cutter head with a defined path, not freehand chiseling. Be honest. The geometry check is to scan a wall, pull a profile every few feet, and compare arc centers and spacing. If those centers line up on a curve with near constant offset, you are looking at a head that tracked on rails or a cradle. That implies a secondary level of precision construction just to guide the primary machine. If the pattern is machine clean, why cling to a hand story that cannot do this? Cutting granite smooth takes steady pressure, a tough cutting edge, and controlled feed, none of which a blast or a hand chisel can hold across a full face, without leaving pits and chips. Do the simplest check. The cut quality check is to grade pit frequency, microfracture clouds, and edge splintering along a test strip. Blasts overbreak and chisels chatter, while a controlled grind or cut reduces both sharply. The surfaces in these tunnels exhibit a quality that even modern blasting struggles to achieve. If the strip reads grind, not smash, how does black powder get credit for a mill finish? Those granite foundations are made of dressed blocks with tight joints and sometimes interlocks, which pushes from rough stacking into high-skill stone fitting. You cannot cheat constraints. The fit check is to probe joint gaps and contact faces and note where even a thin shim refuses entry. Then ask for the instruments that let a crew hold that tolerance outdoors. This isn't just dropping blocks. It's precision assembly of massive components. If the fit looks master grade, where are the tools and the trained hands that make master grade happen on the rush job? Tight fit boosts durability and load spread, which is what you do when you want a structure to last for centuries through weather and ground shift, not when you're sprinting to plant temporary wood across a gap. Stop buying it. The design choice check is to list what a speed-first builder would pick. Cheaper, rubble-filled footings, looser tolerances, quicker set, and compare those picks to dressed, interlocking granite. The choice made was the most durable, most expensive, and slowest option available. If the observed choice screams permanence, why would a speed-paid builder buy forever when paid for today? The finish we see tells on the tool that made it. When quality beats the advertised tool's ceiling, the tool list is wrong, or the story that sold it is. And in either case, the work speaks louder than the book. Look. The capability check is to line up maximum achievable finishes for hand chisels and black powder on granite versus the tunnel's surface metrics. There is a physical limit to the quality a given tool can produce. If the tunnel sits above that ceiling, what else can we call the hand and blast story but fiction? The resource list in the public tale reads short and simple. Laborers, lumber, iron, simple tools. But the stonework and walls point to quarries, cutters, rigs, and experts. Think. The manifest check is to ask for source quarries tied to these specific stones, for transport gear sized for them, and for on-site cranes with the base width and mast strength to swing them. These are not trivial items. They are the core assets of a heavy construction company. If this manifest never shows, how did the hard assets land where they did, in the shape they did? A rotating boring machine, even a simple one, needs a power plant, feed control, lubrication, tools that wear and need swap, and trained operators who read rock, none of which is a footnote on a project like this. Be honest. Lay out the parts list for a cutter head and the service items it burns through. The cutting teeth alone, whether steel or something harder, would be a major consumable item, needing constant replacement and resharpening, if the cutter had to. Eat fuel and teeth and oil. Where is the paper or the junk pile from that appetite? The workforce papers talk about thousands of laborers and foremen, not battalions of master masons and machine techs. And those skill sets are not plug and play. They take seasons to grow. Reality does not care. The roster check is to scan roles and pay grades for titles that match high-skill stone and machine work. An experienced machine operator or master mason would command a significantly higher wage than a general laborer. If those roles do not appear in numbers that match the stone output, where did the skill come from on the days the stone was cut and set that clean? Trying to explain a sleek, high-tolerance output with a low-tech resource list is like claiming a finished clock was made with only a mallet and a nail. The parts do not add up. Do the simplest check. The sufficiency check is to match each observed feature, tight joints, smooth arcs, heavy lifts, to a resource on the official list. The official list provides a hammer for a job that required a micrometer. If the list cannot carry those loads, what else is the list but incomplete, or the story that built it by hand but a lie? The claim about pre-existing routes and tunnels shifts the job from creation to restoration, and restoration matches a lighter tool set and a cleanup schedule more than a deep-bore timeline. You cannot cheat constraints. The context check is to look for weathering inside tunnels, patina patterns, mineral films, rounded edges that should not appear fresh if cut that season. Geologists can date a rock surface by its weathering rind. If the walls read older than the paperwork date, why is cleanup not the better fit? If the tunnels were mostly there, then the debris volumes shrink to something a cleanup crew with shovels and carts can handle, and the workforce on the books can suddenly match the task. Stop buying it. The volume check is again decisive. Compare expected spoil from new bores to the actual mass in embankments and side dumps. The math is simple. Volume of tunnel equals volume of spoil. If the mass is too small for fresh cuts and too neat for wild blasting, does cleanup not explain the numbers better than full excavation? The granite foundations also make sense under an inherited frame lens. If you come upon ready-made, overbuilt stone footings, you would be foolish not to use them as bases for your quick wooden trusses. Look, the era mismatch check is to align wear, toolmark styles, and dressing profiles on the stone with the lighter, disposable timber above. The stone speaks of a patient, heavy-duty construction culture, while the wood speaks of a fast, lightweight, and replaceable one. If the base reads timeless and the top reads temporary, why force them into one build story instead of two eras dovetailed by need? Shift the frame, and the contradictions ease. The heavy stone and smooth walls are not products of a sprint. They are the skeleton that the sprint latched onto to move iron from point to point, fast. Think. The coherence check is whether this reuse model fits the incentive of speed with lower new excavation and leverages existing hardpoints. A smart builder always uses what's already there to save time and money. If the reuse model resolves the speed, cost, quality clash cleanly, why cling to a creation tale that keeps breaking under every test? The written tale says grit beat granite with basic means, but the stone and the walls say something else. Precision, permanence, and methods that do not match the tool list. Be honest. The record check is to ask a straight choice. When written lines fight the measured surfaces and masses, which side do you trust? Paper or rock? In any engineering audit, the physical artifact is the final authority. If rock carries the loading and paper carries the poetry, who wins in a build audit? Failure patterns tell the truth a long time after the work is done. Wood rots and burns, iron rusts and cracks, and quick fills sink, while tight stone fitted well tends to sit and endure. Reality does not care. The wear and tear check is to track which parts failed early and often along similar lines elsewhere, wood and iron, and which parts barely moved. A granite core. The parts that match the official story's constraints are the same parts that have required constant maintenance and replacement. If the durable parts pattern like ancient grade work, while the disposable parts pattern like rush work, do they not read as different origins glued together? The wooden pieces did fail and got swapped. That part fits the sprint. But the stone cores and smooth tunnels held under mountain weather for over a century and a half with far less drama. Do the simplest check. The maintenance check is to compare anecdote and visible patchwork on the wood and iron against the quiet, unchanged fit of the stone. The parts that should be weakest, the monumental stone bases, are the strongest. The parts that should be quick and strong, the trusses, are the most fragile over time. If the keeper parts are the ones that are supposedly out of scope for the sprint's tools, why does the long-term record spare them while punishing the sprint-grade parts? Risk on a pay-by-mile push means cut corners where you can. And pouring time into permanent stone for a temporary span raises risk of missing the money window, which no sane builder does on purpose. You cannot cheat constraints. The risk check is to frame a choice. Push fast with wood and bank the mile payments, or sink time into stone and risk losing the race and defaulting on loans. For a project on the financial edge, the second choice is not a choice. It's bankruptcy. If the second choice is a career ender under that incentive, who signed off on it under their own name, and why? The durability split is stark. The supposed sprint grade system shows the expected pains in the expected places, but the stone cores behave like they belong to a different class. Like finding a cup that should crumple, but acts like a steel block. Stop buying it. The origin check is to treat the system as two subsystems, disposable tops and permanent bases, and ask which story explains their aging paths. The aging curves are completely different. One degrades on a scale of decades, the other on a scale of centuries, if not millennia. If the aging says two parentages, how can one parent's story be true? Any builder listening to this mess of choices would call it absurd. Nobody builds a forever foundation under a throwaway bridge when the pay reward is speed now. And nobody adds precision steps to a day rate sprint. Look, the sanity check is to ask whether a crew on the hook for days and miles would pick the slowest setup under the fastest pay. It is a fundamentally irrational business decision that is repeated over and over again along the line. If that pick is impossible in practice, do we still call it history or a forgery of history? Trade-offs do not go away because a story wishes it. Speed fights quality and cost, and choosing all three at once is fiction, not fieldwork. Think. The triangle check is to classify the wooden truss on top as fast and cheap, and the stone base as slow, high quality, and costly. A project manager lives and dies by balancing this triangle. You can have two, but you cannot have all three. If both sit in the same so-called sprint package, are we not staring at two opposed philosophies crammed into one timeline without a reason that fits the money and the manpower? At the heart, this is the fatal clash. A single build under one incentive cannot chase opposite goals at the same time, not without leaving a trail of chaos we do not see in the stone. Be honest. The consistency check is to pick a lane, speed or permanence, and track decisions downstream. Every single decision, from tool choice to material sourcing to labor skills, flows from that primary goal. If the observed choices split cleanly into two lanes, one sprint and one shrine, does that not say two origins, not one confused foreman picking badly all day? The official tale leans on a string of worst possible choices, as if the builders chose slow when paid for fast, picked permanent when asked for workable, and reached for precision with a labor pool hired for sweat, not craft. Reality does not care. The rationality check is to stack those choices against any real-world job where time equals cash, and show me the foreman who survives such a run. In the real world, that person is fired for incompetence and bankrupting the company. If no practitioner would live through those calls, why pretend they did here? The stone, the tool marks, the incentives, the logistics, the skills, and the observed failure modes all point in one direction. The hand and black powder story fails when you push it against the work itself. Do the simplest check. The verdict check is whether the official explanation can explain smooth, arcing walls in granite, tight megalith joints, missing industrial support trails, and incentive-breaking choices. It explains none of them. It waves them away. If it cannot explain these core facts, what else can we call it but insufficient and wrong? This is a hypothesis. The railroad crews did not create the hardest parts, but instead found and cleared an older, high-tech framework. It worked by using existing stone bases and tunnel bores while laying track and setting quick wooden trusses on top. It fits because it honors the speed incentive, explains the small debris volumes and matches the machine-like tool marks without inventing new magic tools. If one clean reuse idea resolves the speed, stone, and surface contradictions at once, why force a creation tale that breaks in every test? The official story asks you to pick paper over rock, calendar over surface, and wishful thinking over basic fit checks. And that is not how any practitioner signs off a job. You cannot cheat constraints. The audit question is simple. When the materials, marks, and money do not line up with the written lines, you reject the write-up and rewrite it to match the build. That is standard practice in every field of engineering and construction. If that is how we work in the field, why make an exception here when the field evidence is stacked and stubborn? The official explanation fails the audit because it cannot carry the tool mark signatures, the scale and precision of the stone foundations, the transport and lift constraints, the speed first pay logic, or the durability split that reads like two parent systems. Stitched together. Stop buying it. The facts on the ground say the sprint parts fail and get swapped, while the stone parts sit like they were born for permanence. The surface finishes read like guided machines, and the missing industrial footprints make a heavy stone sprint absurd. How is the official tale anything but a fiction that ignores physics, logistics, and time? Look closer, ask for the checks, and follow the constraints. Because reality does not care about a heroic paragraph when the wall says machine and the base says megalith. Who benefits? If you want more calm, forensic breakdowns that force the story to answer the stone, join us for the next case.